Hello everyone. So I'm the leader, Kok Ray, and I'll be presenting our CA assignment. So my members are Oh Kai Hong, Lo Wei Hong, and Kang Zawan. Our lecture section is D1213, and our lecturer is Madam Julie. In this video, I'm going to be explaining Postfix notation, stack diagram, zero address, for one address and two address, three address, and all that. So first, this is the program execution expression. So this is basically the question. X equals to bracket A plus B multiplied by C and then minus D bracket D minus E divided by F plus G. Postfix notation is basically that we move all the addition, subtraction, and addition, subtraction, multiplication, and division all to the back. So that the answer we get is x equals to AB plus C multiplied DE minus FG plus divide minus. So how do we get this answer? First of all, you need to look at this. So as I mentioned, you need to put all the multiplication, addition all to the back. So here, FG, F plus G is moved to the back. You can, so next, how do you think we get this answer? So first we need to solve is the bracket ones first, as this is the, we need to solve this before we can solve the whole equation. So here you can see that we move the subtraction to the back and all that, and we move the addition to the back as well. You can see that here is because we move DE subtract, okay, and then we move here AB plus. We move all the addition, subtraction, multiplication all to the back, but we move the ones in the bracket first. So you can see here AB plus C multiplied minus DE minus divide FG. You can see here that we multiply AB plus multiply C. In this question is AB multiply AB plus together first and then multiply C. So we do plus first. We do the addition first. And then we do the multiplication. So we put multiplication to the back. So it's C multiplied minus DE. So here, there's actually a divide here in the middle. So this one, we actually haven't solved it. So we need to solve. So we need to move the division all to the back. So it's FG plus divide. And then you can see that there's minus. So we need to move this to the back as well. The answer we get is AB plus C multiplied by DE and minus FG plus divide and minus. So next is stack diagram. How we get this answer is that when we pick a postfix notation answer, and then we use it to convert it to a step diagram. So first you can see x equals to AB. So step one is A. The first one is A. So we load. So right here the first one is A. So the second one is B. And then B is always placed at the top. It cannot be placed in the bottom. So it's A, B, A. And then you can see that there's plus here. There's an addition here. So we need to put that here. So AB plus. So the answer here in step 3 is A plus B. Now that this is finished, we need to load C into the diagram as well. So A plus B, and then we put C at the top. And then as there's a multiply here, we need to multiply this together. As AB plus AB plus is first, so we put a bracket here, and then A plus B multiplied by C. So now we need to load D as well. So A plus B multiply D, C, and then put a D at the top. And then as D here, you can see there's DE. So we need to load D at E as well before we do the subtraction. Because the subtraction at the back, we always follow the answer. So it's DE minus. So minus we put at the minimum is always D minus E. Okay, now that we finish this, we need to load F. So load F and G. So F we put at the top first, and then we load G. So FG. And then F here, there's a plus here. So F plus G. There's now division. So division is top divide by bottom. So DE divide and then divide by F plus G. And then you can see that there's minus here. So lastly is the minus. So you can see that the whole diagram is A plus B multiplied by C minus D minus E, and then divide by F plus G. So in the end, the answer we get is this. So next, I'm going to be discussing zero address machine instruction. So this is the question that question earlier. We are going to convert it into postfix notation. So this postfix notation is that we already solved it already, so we don't need to discuss it lah. So I'm going to be directly doing the 0 address. So as you can see here, it's A, push A and push B. So this is following the postfix notation. So A, B, push A and push B. So this is the command. Push is the command. So here we do addition. So add. So it's A, B, A, add B. And then we push C and multiply. So it's A plus B multiplied by C. Okay, so now we push D and E. So now we get what? So it's push D and push E together. And now subtract. So it's D minus E. So here we lastly we push F and G, and then we put addition. So in the addition, divide, and subtraction, and then lastly we pop X. So this is pop X is actually to store this address lah. Now that we're done with 0 address, we are going to be discussing 1 address machine instruction. So here we actually don't need to do a postfix notation. We can directly follow the question. So here the command is load, not push. So here the command is load A. So we load A into register AC, into the accumulator. So now that we're in 1 address, we can directly do addition. So it's load A, add B. So it's A adding B. So addition is add B is plus B. Now that we finish this, because in the bracket we have to store it first. So we store it into register Z. Now we need to load D, and as we need to do the bracket once first, so we load D. Now load D and subtract E. So D, E, and store to register Y. Now that we finish the bracket once, we still have the last one, which is divide by F plus G. So F plus G is in the bracket, so we need to do those ones first. So it's load F and then add G. Now that we finish loading and adding this all, and then F plus G is finished, we need to store it into register S. Lastly, we load the Z, which is A plus B. Here, in this scenario, we already store it into register Z. So we just load register Z here and then multiply by C. Now that this is finished, we subtract Y, which is the one that we store in register Y just now, which is D minus E. That we'll finish this, we just need to divide by F plus G, right? So we just divide S. The one F plus G is already stored in register S, so we just divide S, which is to divide F plus G. Now we store it into register S and X, and then we finish the equation. Then we finish 1 address machine instruction. So that is all for 1 address, and then I'll be discussing 2 address now. 2 address is actually quite simple. So this is also just follow the question. Instead, we just change the commands. Just change load to push, and to move. Now we can just move A into X. So this is actually to move A into register X, and then from this we add B into register X as well. And lastly, we can directly do this. Actually, we can just directly multiply C into multiply C here. And then now you can notice that we move Z. It's not in register X anymore because we actually just leave it here. We actually don't need to store it also. Z, D. What is the meaning of this? Actually, to put it simply, we just load D into register Z. Now, D need to be subtracted by E. So you can see here, we subtract E. So D subtract E. Now we need to do the F plus G part, which is the last part. So we move F and then we add G. So it's F plus G into the register Y. Now that we finish the question, we just need to divide and then put them all together. So here you can see that we subtract Z in X. As we previously stored the A plus B multiplied by C into Z. Now we just subtract Z. Lastly, we just divide Y and in register X, and it's automatically stored already. So we don't need to do anything. Lastly is the 3 address. I'm going to be discussing the 3 address machine instruction now, which is this question is actually the same question, but that we just do it in 3 address. For 3 address, it's actually even more simpler. We don't even need to load or move anything. we just directly do the question. So we just do add AB into register X. So here A plus B. So now here we can subtract D and E in register Y. So D subtract E. Now that we finish this, we need to do F plus G, which is the last part. So we need to do add Z FG, which is to F plus G in register Z. Now I finish all of this. We multiply X, multiply the value in X, register X, with C. So now is A plus B multiplied by C into register X. Now that this is finished, we just need to subtract Y. So previously we already do the value in D minus E in Y. So now we just subtract it here. Lastly, is divide Z. So in register Z, we know that it's F plus G. So here we divide F plus G in register X. That'll be all, and thank you for watching.